Hello students, welcome to the second lecture on the lecture series on permutation and combination. So in the previous lecture, we have learned what permutation was and some different properties of permutation and some types of problems that are usually being asked on permutation on various competitive exams. So in this lecture, what we will do is we'll continue the theory discussion and we'll actually discuss in this lecture about combination. Okay, what is combination? Okay, so what kind of properties does combination brings to the table? And what kind of question that are usually being asked on combination on various competitive exams. Okay, so let's go forward and see the problems and some types of concepts that are based on combination in this lecture. So we'll be covering the concepts and types of problem on combination. Permutation is already completed. Okay, so let's try to see what is combination. Okay, so basically in case of combination, what we want to do is we are interested in finding the number of distinct groups that can be formed without repetition. Okay, so regardless of the order of the selection. So previously order mattered. Okay, in this lecture or in this combination concept, the order doesn't matter. Okay, so in how many ways? So basically if you have a group of people, okay, so let's say you have 8 different people, right, and you want to make a committee out of it. Okay, you want to make a committee of 3 people and you want to sit them in a row. That is 3 people. Okay, so for to make a committee, you don't really want to what order them, right? All you need is 3 people. Okay, but if you want to what make them sit in a row, then first you have to choose 3 people and then you have to see different 3 combinations that are possible with them. Okay, so but in case of combination, all you need to do is you only have to select 3 people out of those 8 people. Okay, so basically that is what here, regardless of the order of selection. Okay, in case of permutation, what happened was first you choose that much, then you see in how many ways can they actually what permute among themselves, or actually what how their order will affect the number of choices. So this concept is actually used in various real life scenarios, such that selecting a team from a pool of players. Okay, so forming committees. So you can actually take another example like so you all know that about the cricket teams, right? So you have 14 players chosen for a what match, right? Or for a series or for a tournament. But for a match, only 11 uh, people can or players can actually play, right? But in a innings, while batting, out of those 11, okay, the batting order can be different. Okay, so think of that from that 14 people pool, you selected 11. Okay, this is what combination is. Okay, in how many ways can you combine 11 players irrespective of their batting order? Okay, but in case of permutation, what happens is how you can select 11 people and how their batting order can be changed. Okay, how many batting orders can they have? That is what. So using these two, this is called permutation. Okay, so the formula to find the number of combinations and n items taken r at a time is given by NCR. Okay, or CNR, and is calculated using what? The formula NCR is equal to n factorial by r factorial into n minus r factorial. Okay, so where n is the total number of items, r is the number of items that we want to choose, that is size of the subset, and this represents the factorial, which is the product of all positive integers up to the given number. Okay, so combination is a mathematical concept that refers to selection of a group of items from a larger set. Okay, where order of selection does not matter. Okay, so it is a way of counting the number of distinct groups that can be formed without repetition, regardless of the order in which the items are actually chosen. Okay, so let's try to see some formulas and properties. Okay, so the number of combinations of n items taken r at a time, denoted as NCR or CNR, that is given by what? NCR is equal to n factorial by r factorial into n minus r factorial, right? So let's try to see some other formula. The second formula is the number of combinations when selecting n items form a set NCN is always what? 1. So the number of combinations when selecting 0 items from a set NC0 is actually what? Always equal to 1. Okay. So the number of combinations when selecting one item from a set of NC1 is always equal to the number of items in the set. And number of combinations when selecting R items from the set of N items NCR is the same as selecting the remaining N minus R items from the set. That is NCR is actually equal to NC N minus R. So let's try to see the sixth kind of property, that is the number of combinations is actually always positive integer. And if N and R are non-negative integers such that N is greater than equal to R, then 0 is less than equal to NCR is less than equal to NC0 is actually equal to 1. Okay, so let's try to see the eight kind of formula, that is the total number of ways to form combinations is equal to the binomial coefficient, which is represented as what? NCR, summation NCR for R is equal to 0 to R is equal to N. So combinations are used in various fields including probability, statistics and computer science for solving problems involving selection and arrangement of items or individuals. Okay, so let's try to see some kind of problems that are usually being asked on combinations. Okay, first one is on selecting a committee, second one is on distribution problems, third one is on arranging letters, then choosing teams, color combinations, identifying subsets, selecting representatives, forming pairs or groups, probability and logically. Okay, so basically these are the 10 types of questions that are usually being asked on combination topic on various competitive exams. So let's try to see the first kind of question on selecting a committee, that is questions that involve forming a committee by selecting a certain number of individuals from a larger group of people. Okay, so basically an example would be, but in a school there are 10 students eligible to be part of the school student council, right? If a committee of 3 students need to be formed, how many different committees can be formed? Okay, so number of ways to select a committee of 3 students from 10 eligible students can be calculated using the combination, that is C and R, that is equal to N factorial by R factorial into N minus R factorial, where N is the total number. So the formula is what? C and R is equal to N factorial by R factorial into N minus R factorial, where N is the total number of students and R is the number of students to be selected. So C 10 3 is equal to 10 factorial by 3 factorial into 10 minus 3 factorial, that is equal to actually 120. Okay, so there are actually 120 different committees that can be formed. Okay, so distribution problems. So problems related to distributing objects among them, individuals or themselves, groups, or where the order distribution doesn't matter. So let's try to see a problem on that. Okay, so a teacher has 20 candies to distribute among 4 students. How many ways can the candies be distributed among the students? So first girl can select 5 books from the 20 books, right? So we have used metaphor right here. So in what? 20C 5 ways. So the second girl can select 5 books from the remaining 15 in what? 15C 5 ways. Okay, so basically here the answer will be 20C. Okay, that is for 5 books, but we have to choose what? 4 students, right? So this will be equal to what? 20 factorial by 16 factorial into 4 factorial, it will be equal to what? So 20 into 19 into 18 into 70 whole by 4 into 3 into 2. Okay, so it will be 5, right? And it will be 3. So 15 into 17 into 19. Okay, so let's try to see another question. Okay, so third one is on arranging letters, that is questions that actually require arranging letters of a word or forming different words using a subset of letters. So how many different arrangements can be made using letters of the word apple? So P5 is equal to what? 5 factorial, right? So here we have 5 different what? Letters. So for the first place it will have 5 choice, second it will have 4, third for it will have 3, then 2, then 1. So 5 factorial. Okay, so P5 is equal to 120. So there are 120 different arrangements of the letters in the word apple. So let's try to see the fourth kind of question, that is choosing teams. Okay, problems that involve selecting teams from pool of players or individuals for a specific task. So in a basketball tournament, there are 12 players and 5 players are needed to form a team. So how many different teams can we perform? Number of ways to choose a team of 5 players from 12 players can be calculated using the combination formula. Okay, let's try to see the combination formula. So C 12 5 will be what? 12 factorial by 5 15 factor. Sorry, it will be 7 factorial into 5 factorial. So it will be actually ultimately equal to 792. So there are basically 792 different teams that can be formed. So let's try to see the color combination. So question that asked for the number of ways to choose a certain number of colors from a set of colors. Okay, so a painter has what? 6 different colors of paint. So if he wants to use 3 colors for new painting, how many different color combination can he use? It will be 6C3, right? Because he has 6 items and you want to choose 3 out of them. You want to choose, okay, not permute. Okay, so the order doesn't matter. So it will be equal to 6 factorial by 3 factorial into 3 factorial. So it will be equal to 6 into 5 into 4 by 3 into 2. So it will be what? 5 into 4, that is equal to 20. Okay, so there are basically 20 color combinations that can be used. So let's try to see the step-by-step solution. So the number of ways to choose 3 colors from 6 colors is what? 6 factorial by 3 into 6 minus 3 factorial, that is equal to 6C3, right? So solving this, what we are left with is 6 into 5 into 4 by 3 into 2. So these two can be cancelled out. So this will be equal to 20. So as you can see right here, there are actually 20 different color combinations possible with these criteria. So let's try to see the sixth kind of question, that is identifying subsets. So problem that actually require finding the number of subsets of a given set of elements, right? So how many subsets can be formed from a set of 4 elements? Okay, so what we want to calculate is how many subsets can we form. Okay, so only 5 can be formed if we don't want to choose anything, right? So it will be what? 1 first. Then if we want to choose one element, so there are 4 options. So 4 sets are possible right here. Okay, so if you want to choose 2 elements, so it will be what? 4C. 4C2 is equal to what? 4 factorial by 2 into 2 factorial into 2 factorial is equal to 1. So it will be only one way. Okay, so we want to consider what? We want to consider 4C3. So 4 factorial by 3 factorial into 1 factorial. So it will be 4, right? So if we want to have what? 4, then it will be 1 only 1. Okay, so for 4 cardinality set we have only one choice. For 3 cardinality set we have 4 choice, and for 2 cardinality set, okay, so it will be what? 2 factorial, so it will be 3 into 2, that is equal to 6 ways. Okay, so these are the total number of subsets that are actually possible. So 4 plus 6 is equal to 10 plus 14, 15 and 16. So 16 different ways are there. Okay, so the number of subsets of a set with 4 elements can be calculated using the formula n square. Okay, so where n is the number of elements. Okay, so 4 square here must be here, not here. 4 square is equal to 16. So there are 16 different subsets. So selecting representatives. Okay, so question arise when candidates need to be selected as representatives from different categories. Okay, so in each student selection, okay, so there are 2 candidates from each grade level, that is from 9, 10, 11 and 12. So if one candidate needs to be selected from each grade, then how many different combinations of representative can be formed? So number of ways to select one representative from each grade level can be calculated using the product of combinations. Okay, so number of ways is equal to C21 into C21 dot 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 dot. So it will be 2 into 2 into 2 into 2. So it will be 2 into 2 power 4. So that is actually equal to 16. So there are 16 different combinations, okay, of representatives. So forming pairs or groups. Okay, problems that involve forming pairs or groups from a set of people or objects. Okay, so in a dance competition, there are 10 male and 8 female participants. The judges want to form pairs, okay, in the competition. So how many different male female pairs can be formed? So number of ways to form pairs of male female participants can be calculated using the product of combination, that is equal to C10(1). C8(1) is equal to 10 into 8 is equal to 80. So there are basically 80 different female pairs. So let's try to see question number 9, or type of question of number 9. Okay, so questions that actually deal with calculating the probability of certain events based on the combinations. So in a deck of 52 cards, what we do is we have a probability of drawing 2 red cards and 3 black cards in a order. Okay, we want to calculate the probability. Okay, so what is the probability that we will be drawing for 2 red cards and 3 black cards in any order? Okay, so the sample space will be 52C5, right? That you can easily see right here. But what is the probability of drawing 2 red cards? Okay, there are basically 13 red cards, so 13C2. So 13C2, right? Then this much plus what? So it will be 3 black cards. Okay, so 13C3. Okay, so if we add these two, okay, so what we are left with is this much whole by 52C5. Okay, this is what will give the probability of what? In a deck of 52 cards, what is the probability of drawing 2 red cards and 3 black cards of in any order? Okay, so total number of ways to do that is 52 factorial by 5 factorial into 5 minus 5, 52 minus 5 factorial. So it will be equal to 25,98,960 rupees. So number of ways to draw 2 red cards is equal to what? 26 by 2 into 6, 22, 26 minus 2. So it will be equal to what? 26 into 25 whole square into 24. That will be equal to 43,80,000, right? So probability is what? Number of favorable outcomes by total number of outcomes. So this will be actually equal to 0.168. So the probability of drawing red cards and then black cards is actually approximately what? 0.168. Okay, so let's try to see the 10th kind of question. Okay, so you have a deck of 5 different colored cards: red, blue, green, yellow, and purple. So how many different ways can you arrange these cards in a row? So it will be 5p what? 5 is equal to what? 5 factorial by 5 minus 5, that is equal to 0 factorial. So it will be equal to 5 factorial ways are there. Okay, so basically what we have here is number of permutation will be this much, so it will be actually equal to 120. So 120 different ways to arrange the 5 different colored cards. Okay, so I believe that's enough for today. Thank you.